this lesson is about understanding the pattern that we have when we do a 45, 45, 90 triangle. That's a triangle that has 45 degrees, 45 degrees, and 90 degrees. Now, here's the pattern that we're going to find. First of all, anytime it's a 45-degree triangle, I need you to understand that what you're looking at is half of a square. Okay, that is what is going on here. So a 45-degree right triangle is always going to be half of a square. So that should help you understand why these sides are always going to be the same. So whatever this, if this is x, then this is x. And it turns out that because we could do the Pythagorean Theorem and solve this. In fact, let me just do this one time. Need a little space to work. Okay. Look, if we have a 45, 45 right triangle, like this one. So, okay, so here's 90 degrees. This is 45 degrees. Look, if this is 45 degrees, if you were to subtract from 180, this will be 45 degrees. So if one angle is 45 degrees and you have a right triangle, the other angle is automatically 45 degrees. Which, by the way, automatically means this is isosceles. If these two angles are the same, then these two sides are the same. So as soon as you see 45 degrees, you know that these two sides are the same. So if one of them is x, then the other one, we can call that x. Now, say if we want to find the hypotenuse. Okay, for a moment, let's call that c. That's to remind us that we're about to do the Pythagorean Theorem, just this once. The whole point is that there's a shorter way than this, but this is the long way. The Pythagorean Theorem, a squared plus b squared equals c squared. So that would be x squared plus x squared is equal to c squared. Well, x squared plus x squared is 2x squared is equal to c squared. Okay, now if I take the square root of both sides like this, square root, that's going to give me c. Okay, just the same way that taking the square root got rid of that squared, taking the square root is going to get rid of the square on this x also. So that's just going to give me x. But the radical 2, nothing I can do about that. So that's going to be x radical 2. Now, so the point is, if you have a 45-45 triangle, this is always going to be your pattern. The legs are both going to be the same, and the hypotenuse is going to be leg radical 2. So it works sort of like a formula, so keep this in your head. In fact, this image will be given to you on the formula sheet. So all you really have, you don't even have to really memorize this because it will be given to you, but you need to understand what this means. Okay, so leg radical 2, x radical 2 on the hypotenuse. Okay, so looking at how that applies to these homework problems. If you understand, okay, that I'm going to have, if this is x, this is going to be x, then this is going to be x radical 2. Well, looking, if I have 4 radical 2, and that's supposed to be x radical 2, guess what x is? Yeah, x is 4. Alright, so this must be 4. So this is 4 radical 2. Okay, so x is 4. Okay, so here are the legs again. So this is supposed to be, alright, instead of x's, this is x radical 2. Since I already have x's in this problem, I'm going to use n's this time. So let's look at this as n. Whoa, that's too small. Let's look at this as n, and n radical 2. Okay, forget about the x's for a second. Okay, so this is like n, and n radical 2, right? But n is 3. So this should be 3 radical 2. So that's going to be 3. If the leg is 3, this is 3, then this will be 3 radical 2. Leg, radical 2. Okay. Alright, again, looking at number 3, consider the pattern. It goes x, x, and then the hypotenuse is x radical 2. Okay, looking at the legs, x, x, and x radical 2 for the hypotenuse. Well, they were kind enough to actually give us x's for these legs, so it matches right up with the pattern that we're trying to learn. X, x, and then this should be x radical 2. But then I've got this 8 sitting here, so that means x radical 2 must equal 8. Now let me just take this and move it off to the side so we can really work on it. X radical 2 is equal to 8, because that's what's here, so it must equal this. So then it's just a matter of solving for x. So when I do this, I'm finding what these legs are. So if I just simply divide by radical 2 on both sides, okay, then that is going to give me x equals, if I just put this in my calculator, I'm going to get 4 radical 2. Alright, and that's the answer to number 3. Okay, number 4 takes a little bit more thought. This is x, so this should be x radical 2. So 7 equals x radical 2. But I'm supposed to find x, so that means I need to get x by itself. So watch this. I'm going to divide both sides by radical 2 to get x by itself. So that way these radical 2's cancel each other out. So far, that gives me x equals 7 over radical 2. Okay, but that's going to give me x equals, so I'm going to put 7 over radical 2 in my calculator right now, see what happens. So 7 over radical 2. Bam! 7 radical 2 over 2. That's what that is equal to. So x is equal to 7 radical 2 over 2. Okay, so that is the answer. That's what x is. Alright, so that's the one case that you have to watch out for. If I give you a whole number for the hypotenuse, you know that the hypotenuse is supposed to be x radical 2. So set it equal to x radical 2 and divide. Okay, what about number 5? Alright, these are the legs. Okay, so whatever this is, so this is leg, and this is supposed to be leg radical 2, right? Now watch this. In this case though, the leg is 5 radical 2. So let me change colors. So the leg is 5 radical 2. So it should be 5 radical 2, 5 radical 2, and then 5 radical 2, radical 2. If you can understand that. That might be a little hard for some of you to understand, but let me follow through and finish this first. Now I know that this is going to be 10. And I'm going to show you how I did that in my head in a second. Okay, but right now x equals 10. But first, let's put it in the calculator. 5 times 5 radical 2 radical 2. So that would look like this. 5 radical 2 radical 2. Okay, and it gives you 10. Now here's why it's giving me 10. Here's why I can do that in my head. Look, watch this. See, what if I told you radical 2 times radical 2 is 2? Guess what radical 3 times radical 3 is? It's 3. Guess what radical 5 times radical 5 is? You guessed it, it's 5. So anytime you multiply a radical by itself, you're just going to get the number. Now look, the reason why that is, what's 5 times 5? 25. So radical 5 times radical 5 is radical 25. But that's a perfect square. The square root of 25 is 5. And see, that happens every time. 2 times 2 is 4, but then that's a perfect square, which gives you 2. 3 times 3 is 9, but then that's a perfect square, which gives you 3. So that's too much thinking. I want you to understand that if you multiply a radical by itself, you're going to get the number back. You can always use your calculator, but I find that it's better if you understand what's going on sort of behind the scenes, as it were. So this one's going to be 10. So watch out for problems like that. Number 6 is back to the easy kind. Alright, if this is 4, then this will be 4, and then this will be 4 radical 2. Okay, let's move on. So look at number 7. Complete the table. If x is 3, then what's y? Alright, if x is 3, then this is 3, 3, 3 radical 2. So y would be 3 radical 2. Okay, if y is 6 radical 2, well then that means x must have been 6, because that would be 6, 6, 6 radical 2. That's the pattern. So x must have been 6. Okay, if x is 7, if x is 7, then this should be 7, 7, 7 radical 2. So y should be 7 radical 2. Okay, if x is 2, then this should be 2, 2, and 2, and then y would be 2 radical 2. Alright, just following the pattern. Okay, so that's number 7. Number 8, an engineer is in charge of attaching guy wires to a cell phone tower. One wire attaches to a point on the ground 60 feet from the tower. Okay, I feel like I need some more lines in here. So this is what's going on. Okay, picture this triangle. Okay, I'm just trying to make it real easy to see. Alright, this hypotenuse is the wire. Now, what about it? 60 feet from the tower. So that means that this part of the triangle down here is 60. They said it was 45 degrees. Okay, so what is the length of the wire? So if this is 60, right, the distance from the tower to where it attaches to the ground, then just using the pattern, this will be 60, and this side will be 60, and the hypotenuse will be 60 radical 2. So that's the length of the wire. That's the exact length of the wire, 60 radical 2 feet. Because this is a real world problem, it makes more sense to make this a decimal. So 60 radical 2. Okay, use the toggle button. So that is approximately 84.9 feet. Okay, but it's because of the 60, 60, 60 radical 2. That's the quick way. Now, could I have used the Pythagorean Theorem and done 60 squared plus 60 squared equals x squared? Yes, please keep that in the back of your mind. If you forget how these patterns work on the special triangles, you can always do the Pythagorean Theorem. It will just take you a lot longer. All right. A little higher level thinking. What is the perimeter of a 45, 45, 90 triangle with hypotenuse 24? Okay, let's slow down a little bit because this is one of those ones that's slightly tricky. All right, we're given that this is a 45, 45, 90 triangle. And we're supposed to find the perimeter. But let's see, we're given that the hypotenuse is 24. So here's my hypotenuse, and it is 20-fold. If we're going to find the perimeter, I need to know what these sides are. Okay? But remember, I feel like I should change colors. Remember how the pattern works. X radical 2. Let's go back to x's. All right, x radical 2. Leg radical 2. So yeah, if I call these x again, so this should be x, and this should be x, and this should be x radical 2. This is what I need to do whenever I'm given the hypotenuse like this. So let me bring this equation over. So look, 24 equals x radical 2. Okay, I'll just copy that over. But if I want to get x by itself, I need to divide both sides by radical 2, like this. Okay, that's going to get x by itself. So 24 divided by radical 2. So 24 divided by radical 2. That's 12 radical 2. 12 radical 2. Kabam. Well, that's not the answer. I don't know why I'm putting a box around it. Maybe a circle, perhaps. Because that's something, but that's just x. So now we know what these sides are over here. So if I go ahead and fill them in, all right, so now I've got the 24 that I was originally given, but now I've got these x's. So I've got this 12 radical 2, 12 radical 2. So of course the perimeter, I'm going to add up all of these things. All right, so the perimeter is going to equal 12 radical 2 plus 12 radical 2 plus 24. So will I have space over here? Yeah. So that's going to be 24 plus 24 radical 2, because 12 plus 12, these are like terms. 12 radical 2 plus 12 radical 2 is 24 radical 2. So as far as an exact answer, this is the best I can do. That's as simplified as it gets. If I wanted a decimal, I could create one. This is not a real world problem. You know, we're not talking about wires or buildings or anything like that. So it's probably good just to leave it in this form. But you know how to make a decimal if you need one. Just put it in the calculator, hit the toggle button. Okay, so that's it for that one. Now, a square has diagonal 14 centimeters. So let's see what's up with that. Here's a square, and here's a diagonal. Okay, and this square, since this is a square, that means these are 90-degree angles. And anytime you split a square in half with a diagonal, you're creating a 45, 45, 90 triangle every single time. And we're given that the diagonal is 14. Okay, so this is 14 centimeters. Okay, so again, this is just like what I was doing a minute ago on problem number 9. The pattern goes like this. The legs are x, x, and then the hypotenuse is x radical 2. Got to get that out of the way for a second. So that means this 14 must equal x radical 2. Alright, x radical 2. So x radical 2 equals 14. Again, I'm going to put this off to the side. So x radical 2 must equal this 14. Okay, so I need to divide to figure out what x is. So again, I'm just going to divide both sides by radical 2. So that's going to give me x equals, let's put that in the calculator, 14 over radical 2, okay? So 14 over radical 2. That's 7 radical 2. So x equals 7 radical 2. So, understand what I'm dealing with. I'm just going to recopy this for a second. So I've got my hypotenuse is 14. I've just found that my legs are 7 radical 2, like this. Okay, so does that mean I'm done? No, I'm not done, because we are supposed to find the area. Okay, the area of this square. Remember, the area of a square is base times height. Well, you know, the area of any parallelogram is base times height. Okay, so in this case, that means the base and the height are both 7 radical 2. So I'm talking about 7 radical 2 times, gotta squeeze it in, 7 radical 2. So what is 7 radical 2 times 7 radical 2? That's the question. Let's put it in the calculator. So here we go. 7 radical 2, get out of there, times 7 radical 2. Got to use your arrow key to get out of there. 98, my friends. 98. So that means that the area is in fact 98 centimeters squared. 98 square centimeters. Okay. That is it for the homework. You may need to watch some of those again to really understand.